Hi, my name's Carly McGinnis. I'm the lead for the Advanced Spacesuit Portable Life Support System, or PLIS, development here at NASA at the Johnson Space Center, and today I'm in the Spacesuit Pressure Garment Subsystem Lab, and I'm thrilled to be joined by astronaut SUNITA WILLIAMS to talk about our advanced spacesuits. So I recently learned that you were in one of our advanced suit prototypes in the Argos facility, which is a reduced gravity simulation environment. Can you tell me about that test and what your experience was?
Sure. This is a great place to be. It's a great time to be here working at NASA. But actually, I'm going to be flying on a Boeing Starliner as part of the commercial crew program. I was in one of these advanced suits in the reduced gravity facility, like you mentioned, practicing getting out of a simulated lunar lander, actually hooking up some electrical connectors or some hydraulic connectors, and then actually taking sandbags and moving them across a simulated lunar surface, just to see how we perform before we go to space, and then when we return from space later this year, we'll do it all over again to see how the body changes in space and what the effects are and if you can do the same tasks. But I tell you what, having done a couple of spacewalks in space in a different suit called the EMU, the Extravehicular Mobility Unit, which is designed to operate in microgravity, not necessarily planetary, this suit is awesome. I love this suit. I love everything about it. The workload in any of these suits is pretty high. However, the advancements that we've made over the years make it a lot easier for many, many reasons. We could talk about that if you'd like to.
Yeah, I would love to, because I've been working on this suit for almost 12 years, and my heart and soul has gone into those technological advancements, so I'd love to hear why it's so much better, because I certainly think it is.
Yeah. So one of the things that I think is really great about the suit is your field of view. In the suit that we use for spacewalks on the International Space Station, you only have so far that you can see, and so you actually have to move your whole body to be able to look to your left or to your right to plan where you're going to go. In this one, you can just sort of lean forward and look up to the right, look to the left, because the visor comes out a little bit away from your head, and so that way you don't have to use that energy. Also, the joints in the suit allow you lots of mobility, a lot more mobility for you to actually raise your hand above your head, and your hips allows you to actually do a knee bend or a squat, get your knee on the ground to maybe pick up something on a planetary surface. So it's really mobile and allows you to do a lot more things than we have in our heritage suit.
Yeah, and as I'm sure you're aware, some of those mobility improvements are because this is a rear entry suit where the hatch swings open on the back and you climb in and don and doff the suit from the back, as opposed to the current suit which breaks at the waist and you have to wiggle up through the upper torso. So that's one of the improvements that helps us move the arm bearings in and get better range of motion. And
I love it also because that way you can don the suit yourself and you can take it off yourself, versus the suit that we had, the heritage suit, you need other people to help you really get into the suit. This one, I think the idea would be maybe hang it on the back of a rover, right? And so then you could get in it from inside the rover, close the door, and then off you go. So I think it's a great idea. The rear entry is really convenient.
Wonderful. So you are a veteran spacewalking crew member on ISS. What are some of the differences that would be expected between a microgravity spacewalk versus a planetary, such as a lunar spacewalk?
Yeah, we call it a spacewalk on the International Space Station and on the shuttle in that time frame, but we're not really walking. We're actually operating on a ISS, an International Space Station, or some type of satellite that has handrails, and you're actually doing hand over hand over hand to move. And so the legs actually don't have to be supportive. You don't need to stand up. You do have a backpack, like you mentioned, that you work on, which has all of the heating and cooling and oxygen, carbon dioxide removal, so it's the same there. But the tasks are really for maintenance tasks or construction tasks in the beginning of the International Space Station. So they're primarily tool heavy here and hand operating to do those tasks. Where the planetary suit, you probably have some tools on you, but you have the ability to actually bring tools with you if you had a rover, and you don't have to carry all of them. And that's convenient because of the things like I was mentioning. If we are going to do some construction on a planetary surface, you want to have your hands free, your area free, the ability to bend down, to dig, to grab, to do something like that. And so this suit lends itself to being able to do that and the legs actually have to support you. Even though it's reduced gravity, on the moon, we still have to be supported. And that's obviously a difference from the space station spacewalks.
Absolutely. And you mentioned the backpack, so I'll tell you, you may know this already, but there's a lot of really cool new technologies. For long-term exploration missions, we're looking at reducing consumables and making the suit more suited for in-field maintenance. So
I love that.
Yeah. So one of the key technologies that we have been working on is a regenerative system that you mentioned, removes carbon dioxide from the suit, and it would completely eliminate a consumable that's in the current suit. So that's really cool and something that we're looking forward to going forward when we go back to the moon.
Absolutely, because these suits are going to take a beating, right? So the moon environment is very rigorous, and we're probably going to have some things that are going to need repairs. And so that type of technology advancements are going to make it so easy. We're not going to have the luxury that we've had in the shuttle days and somewhat here on the commercial crew days where we send a suit back home. We're going to want to have the suits there and have the crew members, the astronauts there, be able to do all that maintenance. So that's awesome. That's really good to hear.
Yeah, and you mentioned that it's a rugged environment on the moon and that the suit is going to take a beating. The suits do get a lot of wear and tear on ISS, and the lunar surface is so much more aggressive. I mean, such a harsh radiation environment. Lunar regolith is, we always say it's like tiny little shards of glass have so much electrostatic charge. They cling to everything. It's very abrasive. So there's a lot of materials development work that's ongoing to try to make it more robust in that environment.
That's awesome. I think we're capitalizing on the lessons we learned from Apollo when we went to the moon, and then ISS as we use these types of spacesuits time and time again, and it's culminating in a really good suit. So looking forward to seeing the real suit as it gets ready to go to the moon.
In addition to Argos, the reduced gravity test facility, there's a lot of other analog facilities like the Neutral Buoyancy Lab, and we've done testing in the Arizona deserts and other desert locations in the U.S. and even recently in Iceland. From the crew perspective, can you tell us, how are these analogs used for training, and how does that help prepare you for spacewalks?
Yeah, I'll quickly start with the NBL, and I have seen the planetary surface in the bottom of the pool, and I have actually just been training for a space station. So I've done in the other suit, the older suit, the heritage suit. I've been climbing around on the space station, looking down there, and say, hey, that looks pretty fun down there. But I know my suit isn't one that would be able to stand up. I have been in early version, trying it out and trying to just see how much mobility you have, and if we could actually adapt it to the space station to get a microgravity test on it. It's great because we have a thing, a foot plate. It allows you to stand still while you're working to let your hands be free. And when we're getting in the heritage suit, you have to turn your whole hip to get your foot into this foot plate. You stick your toe in, and then you have to really move your whole leg like this to get in. And in this new suit, you just put your toe in, and you can just turn your ankle like you can naturally turn your ankle, and you're snapped up right in immediately. And it was so convenient. You can also, in the new suit, in that foot restraint, you can lean practically all the way over. You can bend your knees. You can move yourself all sorts of ways, which the heritage suit could not. So the NBL gives us an environment of neutral buoyancy. As we work here in Argos, one of the things that was obvious to me is I felt my body was the load alleviated, but my arms still weighed a lot. So in the neutral buoyancy lab, everything is equally unweighted, and so it allows you to extrapolate a little bit more, a little bit closer to how the suit is going to work. And then when we go to these other analog areas, it gives you the real terrain. In water, we do a little negative training because it's a little bit hard to get going in this big, massive suit, that momentum, and it's really easy to stop. Versus if you are in air or microgravity or microgravity or space, whatever, it's super easy to move that momentum, but then it's hard to stop. So it's a little bit opposite training. You have to keep that in mind. So these different types of analogs and the NBL and Argos here, that allows us to put the whole picture together and really be ready for what we're gonna face when we get to the moon.
That's so interesting, putting together the pieces of all the different analog experiences and putting them to try to in totality simulate the spacewalking experience, because you can't do it in any one training facility.
Unfortunately we don't have a space room.
Or an anti-gravity chamber. We've been working on it, but it's just not coming together. The suit is a pressure vessel, so it's inflated like a balloon, and that if you think of a basketball that's inflated, it's hard. And so the suit is hard. The soft suit is hard when it's pressurized, and you actually have to work against the suit materials to articulate your limbs. And that's true of the current suit and the advanced suits. So, can you talk about that a little bit?
Sure.
How does that make your job more difficult?
Yeah. I mean, I'll just start like right from the hands, right? So your gloves, it's like, you're wearing snow gloves and you're trying to do some meticulous work when you're doing things with your hands. And not only that, those snow gloves are like hard, like you mentioned. And so when you're putting your fingers, using your fingers, they're going to be hitting that end of it. And every spacewalk I've come out of, my hands are just like really tired because your ends are getting hit like pretty hard, and then you're also trying to grip things. Obviously, the way we use our hands is gripping, right? You're trying to grip a tether or a piece of equipment or a handrail. Same will be true in the lunar suit. We're going to be holding tools or driving maybe or something, right? So you want to have gloves that fit you really well so that hand fatigue is not as bad and that wear and tear on your hands is not as bad. These suits right now have the same gloves, so that is still going to be a factor. One of the cool things about this suit, and a little bit different again from the Heritage suit, has bearing which are a little bit wider on the shoulders, and it makes it a little bit hard to like bring your arm over to your work site or move your arm up. You're sort of like having to figure out how to move it. These, with the bearings a little bit closer in, you can actually use your arm like your normal shoulder would be, so you can come across your body. You can come up around your head, to close your sunshade or to reach something that might be overhead. So it's really a lot better. And things I mentioned real quickly about the legs and also the hips, the increased joints in the hips and legs, which provide the support which we'll need on a planetary surface, also allow you to swivel. So one of the real great advantages I mentioned about the field of view from the helmet is enhanced even more so by the hips, because you can swivel versus trying to take your whole body and move your body like around, turn your body pivoted. When I'm talking to some of the newer astronauts, part of the thing that they ask when they get in the suit is like, how do I move? This is so weird. I'm in this big balloon. I don't know really how to maneuver myself around. I'm like, you have to just get used to operating your body a little different way than it normally does. Work with those joints. Don't fight against it, because you will lose in that pressurized suit. In this suit, it's actually a lot closer to the way your body works, and so I think some of those lessons might be bad lessons learned as we get into the new suit, because take advantage of how your body actually moves.
Right.
It's great.
Yeah,
it's really, really good.
That's what we're trying to achieve. So can you talk for a minute about what you think? Why do we have a spacesuit? Why do we send people to these places? NASA also does a lot of unmanned rover exploration, but we also develop spacesuits, and so why do we do this?
Yeah, the spacesuit, it is, the highlight, the pinnacle of actually going to space. It is its own spacecraft, like you've mentioned already about the things that are in it, how its components. It keeps you alive. It allows you to do work. It allows that person to be hands and eyes and feet on the scene doing the activity. We can program robots, and we've done it so well. And with advanced technologies, we've been able to put algorithms in there so they can do neat things, but they're all subject to what somebody potentially thought beforehand and incorporated. The human in the suit doing the activity can make that decision. Mm-hmm. Do I go right? Do I go left? Do I pick this up? Is it worth it? Do I spend time here, or do I go over here? To really enhance the science that we're going to do when we get back to the moon. And the spacesuit obviously is what allows us to do that. Yeah. So making it comfortable, making it work easy, and all that kind of stuff, as well as protect us for, the extreme temperatures, the radiation, the lighting, meteorites on a ISS spacewalk. Suit is really key.
All right, Sunny, thank you so much for coming out this afternoon and talking to me about your experiences as a spacewalking crew member. Yeah, and thank you so much for your work developing our advanced suit technologies.
I love it.
Yeah.